What if, right now, an alien spacecraft is silently drifting through our solar system, disguised as nothing more than an ordinary comet? What if its trajectory, its glow, and even its strange chemical signature are all subtle hints that we're not alone, but being studied? Today, we're diving deep into the mystery of 3I Atlas, a newly discovered interstellar visitor that has scientists scratching their heads and stirring debates about whether this is just a bizarre cosmic rock or something far more extraordinary. This isn't science fiction. This is happening right now in our solar system. On July 1st, 2025, a telescope in Chile picked up a faint, fast-moving object. At first glance, it looked like a comet. Nothing unusual there. Astronomers track new comets all the time. But as more data came in, it became clear this was not an ordinary discovery. The object was moving far too fast to be bound to our sun. Its orbital eccentricity was greater than 1, meaning it wasn't looping around the sun like planets and comets do. Instead, it was simply passing through, a visitor from another star system. This made it only the third confirmed interstellar object we've ever seen, following the famous Oumuamua in 2017 and 2I/Borisov in 2019. That alone would have made it historic. But as astronomers soon discovered, this new object, officially named 3I Atlas, was unlike anything we had ever encountered before. When telescopes like Hubble and even the powerful James Webb Space Telescope turned their gaze toward 3I Atlas, the first mystery emerged: its glow. Most comets shine because sunlight reflects off the dust and gas they release. But in this case, the dust cloud around 3I Atlas was incredibly thin, what astronomers call optically thin. There simply wasn't enough dust to scatter sunlight and produce that bright glow. So where was the light coming from? If it was just reflected sunlight, then the surface of 3I Atlas must be unusually bright, perhaps even mirror-like. Depending on how reflective it is, the object could be anywhere between 10 kilometers and a staggering 46 kilometers in size, larger than almost every comet we've ever seen, and far larger than what we'd expect from an interstellar visitor. And if it wasn't reflecting sunlight, then the possibility arises that it might be generating its own light, something no natural comet or asteroid has ever been seen to do. Adding to the intrigue, the glow wasn't pure white. Observers noted a reddish tint, reminiscent of Kuiper belt objects coated in complex organic molecules. But Harvard astrophysicist Avi Loeb suggested another possibility. The red glow might not be reflection at all, but active emission, like a powered spacecraft. As weeks went by, another mystery appeared: its trajectory. Most interstellar objects arrive at random angles, crossing through the solar system with little regard for planetary orbits. But not 3I/Atlas. This object's path was almost perfectly aligned with the ecliptic plane, the flat disk where all the planets orbit the sun. That might not sound dramatic, but the odds of such an alignment happening randomly are tiny, about 0.2%. Even stranger, 3I Atlas's path takes it close to multiple planets: Mars, Venus, and Jupiter. The chance of an interstellar rock passing so near to not just one, but 3 major planets is almost vanishingly small, around 0.005%. For some astronomers, this looked eerily like the kind of trajectory a probe would take, slingshotting past planets to maximize encounters, just like we design missions for Voyager or Cassini. And as if that weren't enough, when 3I Atlas makes its closest approach to the sun, its perihelion Earth will be hidden on the opposite side of the sun. From our vantage point, we won't be able to see it at all during the most critical phase of its journey. To some, that looks like a cosmic coincidence. To others, it looks like stealth. When the James Webb Space Telescope finally turned its infrared gaze on 3I Atlas, astronomers expected to find the usual signatures of a comet: water vapor, carbon monoxide, maybe some cyanogen gas. Instead, what Webb revealed shocked everyone. 3I Atlas was surrounded by an enormous plume of carbon dioxide. Not just a little CO2, this was a vast, spherical halo stretching hundreds of thousands of kilometers into space, nearly half the size of the sun itself. But here's the catch: the levels of water vapor were extremely low. In fact, the ratio of carbon dioxide to water was about 8 to 1. the highest ever recorded for any comet. Normally, water dominates. For 3I Atlas, it barely registered. Imagine expecting a glass of pure water and instead finding it's almost entirely carbon dioxide. That's how strange this discovery was. Even more baffling, there was no visible tail. Comets, as they approach the sun, usually grow long, glowing tails as sunlight pushes dust and gas backward. Yet 3I Atlas remained stubbornly different. Despite its brightness, despite its massive plume, it lacked that defining feature. This raised a troubling question. If the dust isn't making it shine, and if the tail isn't there, then once again, we're forced back to the idea that the light is coming directly from the object itself. The brightness of an object in space is a tricky puzzle. If something is large and dark, it can shine as brightly as something small and shiny. So astronomers have to balance reflectivity, called albedo, against size. For 3I Atlas, calculations showed a paradox. If its surface reflects poorly, like a dull rock, then it must be enormous, up to 46 kilometers wide. That would make it millions of times more massive than Oumuamua or Borisov, the two previous interstellar objects. But here's the problem. Statistically, that makes no sense. Interstellar space simply doesn't contain enough giant rocks to deliver one this big so quickly. The odds are like buying a lottery ticket once and immediately winning the jackpot. On the other hand, if 3I Atlas is highly reflective, like metal or even a mirror, then it could be much smaller, maybe around 10 kilometers or even less. But then we face a new mystery. What natural object shines like a mirror in deep space? No asteroid or comet we know of behaves this way, which leaves us with a possibility that makes some scientists uneasy: an artificial surface. To put this in perspective, think back to 2017 when we first detected Oumuamua. That interstellar visitor baffled astronomers because it was elongated, strange, and accelerated slightly as it left the solar system without showing any signs of outgassing. Avi Loeb was one of the first to suggest that Oumuamua might not have been natural at all, but perhaps a thin, reflective sail, maybe even an alien probe propelled by sunlight. At the time, many dismissed this as wild speculation. But now, with 3I Atlas, we're seeing another interstellar visitor breaking the rules. Different in detail, yes, but equally confounding. Instead of a thin shard, this one looks like a massive glowing giant, or perhaps a cleverly disguised spacecraft shedding a controlled amount of CO₂ while hiding its true nature. Adding to the strangeness, telescopes detected a reddish hue in the glow. In ordinary comets, this can come from organic compounds baked by cosmic radiation. But Loeb and others have proposed something more daring. Maybe the red glow isn't reflected sunlight at all. Maybe it's emitted light, a glow from within. Think about it. If 3I Atlas were generating its own illumination, its apparent size could shrink dramatically. What looks like a 20 or 40-kilometer monster could, in reality, be a much smaller craft, just hundreds of meters wide, camouflaged in a cloak of light. But what kind of natural object produces its own light in interstellar space? Radioactive decay? Thermal emission? Possible, but unlikely. Sustaining such brightness over billions of years would require an almost impossible energy source. Unless, of course, the energy isn't natural at all, but technological. And then, the trajectory keeps raising eyebrows. 3I Atlas isn't just passing through randomly. It's on a retrograde orbit tilted only 5 degrees from the planetary plane. It's making precise flybys. October 3rd, 2025, a close pass by Mars, within 29 million kilometers. October 29th, 2025, its closest approach to the Sun, perfectly timed when Earth is on the far side, unable to see. Later in 2025, a close swing by Jupiter, just 33 million kilometers away. The combined probability of these alignments by chance? About 1 in 20,000. That's the kind of precision we usually associate with mission planning, not random space debris. And when Earth is blind, hidden behind a sun, could 3I Atlas be performing a maneuver? Loeb calls it a possible reverse Oberth maneuver, a high-thrust braking move that could allow a spacecraft to slow down and remain in the solar system, rather than just slingshotting away. If true, we might be witnessing the most discreet arrival in human history. Of course, not everyone agrees. Many astronomers caution against jumping to conclusions. David Jewett of UCLA, for example, points out that the dust production rates measured, between 6 and 60 kilograms per second, are well within normal comet ranges. The ejection velocities, too, look comet-like. In this view, the lack of clear gas emissions isn't evidence of alien technology, but simply because 3I Atlas is still far from the Sun. As it moves closer, they argue, heating will intensify and the cometary activity will become obvious. It's a reasonable explanation. But then again, reasonable explanations didn't quite work for Oumuamua either. So here we are, caught between two possibilities. Option 1, 3I Atlas is a bizarre but natural comet, teaching us that interstellar objects can be stranger than anything we've yet cataloged. Option 2, it's not natural at all. It's technology. A probe. Maybe even a nuclear-powered craft quietly observing our solar system. Either way, the implications are staggering. So let's ask the bold question directly. Could 3I Atlas be a spacecraft? If it were purely natural, it would already be one of the strangest comets ever found. Its size estimates defy probability, its chemical composition is unlike any other, and its trajectory seems almost too perfect. This is exactly why Professor Avi Loeb and his collaborators have raised the provocative possibility 3I Atlas could be an artificial probe. Think about it. We designed spacecraft to use planetary gravity assists to save fuel and maximize encounters. We sometimes even hide missions behind the Sun to perform maneuvers without Earth's interference. When we look at the flight path of 3I Atlas, it resembles the very strategies we use. Coincidence? Possibly. But at some point, coincidence begins to look like design. Another point of curiosity is the sheer brightness of this object. If the light isn't all from reflection, then it might be self-generated. But how? One idea is radioactive decay, heavy elements inside the object glowing faintly over time. But to shine this brightly, it would need an enormous supply of unstable isotopes, something very unlikely for a rock floating in interstellar space. Another option is thermal emission, internal heat radiating outward. But again, the power required is immense. Which brings us to a fascinating possibility. What if 3I Atlas is nuclear-powered? A reactor aboard a spacecraft could generate light and heat, maintain systems over long interstellar journeys, and even provide propulsion. To maintain its observed brightness, scientists estimate it would need to produce energy on the scale of gigawatts, comparable to several large power plants. Now ask yourself, what natural object in deep space can do that? The answer is simple, none that we know of. If you wanted to send a probe into another solar system, stealth would be critical. You wouldn't want to advertise your arrival too obviously. And what do we see with 3I Atlas? A trajectory aligned to the ecliptic, maximizing planetary flybys. A perihelion timed perfectly so Earth is on the far side of the Sun, blocking our view. A brightness that could disguise its true size, making it seem like a giant rock instead of a compact craft. Each of these alone might be coincidence. Together, they begin to resemble a pattern. Even more unsettling, when astronomers modeled its path, they found the chance of these alignments happening naturally was about 1 in 20,000. Those aren't the odds of rolling a normal dice. Those are the odds of rolling a loaded one. Of course, extraordinary claims require extraordinary evidence, and many astronomers are quick to point out that natural explanations do exist. David Jewett and others remind us that comets can be highly variable. Some shed lots of dust, others barely any. Some release water, others are dominated by carbon compounds. Nature, they argue, doesn't always follow neat rules. They also point out that 3I Atlas is still far from the Sun. At its current distance, water ice doesn't sublimate strongly. As it gets closer in the coming months, we should see more gas emissions. If that happens, it would support the comet theory. So while the alien probe idea is exciting, the scientific consensus, at least for now, leans toward 3I Atlas being a very unusual but natural comet. Still, consensus is not proof, and the debate remains alive. Back in 2017, when Oumuamua streaked through the solar system, it too defied expectations. It accelerated slightly as it left, without showing any visible outgassing. It was elongated, tumbling, and oddly aligned with the local standard of rest, essentially stationary compared to the background stars. Some argued that sunlight pushing on a thin, reflective surface could explain its acceleration, exactly what you'd expect if it were an artificial light sail. The scientific community debated fiercely, and to this day, no natural explanation has fully satisfied the mystery. Now, with 3I Atlas, we may be seeing history repeat, another visitor, another enigma, and another chance to confront the possibility that we are not alone. Fortunately, we won't have to rely on speculation forever. The next few months promise critical opportunities to unlock the truth about 3I Atlas. October 3rd, 2025, the object makes its close approach to Mars. There is talk of using the high-rise camera aboard the Mars Reconnaissance Orbiter to capture high-resolution images. If successful, this could give us our best-ever close-up view of an interstellar visitor. October 29th, 2025, at perihelion, 3I Atlas swings close to the Sun. This is when cometary activity usually peaks. If it's a natural comet, we should see strong gas emissions. But remember, Earth won't be able to see it then. Only space-based telescopes like James Webb or missions stationed elsewhere might catch the action. December 2025, 3I Atlas makes its closest approach to Earth, though still at a safe distance. By then, we'll know far more about its true nature. The Vera C. Rubin Observatory is also beginning its all-sky surveys. It's expected to detect dozens of new interstellar objects every year. If 3I Atlas is truly unique, that would be telling. But if more objects like it appear, bright, strange, and oddly aligned, it could mark the beginning of a paradigm shift in how we view the cosmos. Why does all this matter? Because if 3I Atlas is natural, then we've just discovered a new class of interstellar object, massive, carbon dioxide-rich, and unlike any comet we've studied before. That alone would revolutionize our understanding of planetary formation in other star systems. But if it's not natural, if it is, in fact, a probe, then we are no longer just passive observers of the universe. We would be hosts to visitors from another civilization. That would be the single most profound discovery in human history, proof that intelligence exists beyond Earth and that it is capable of crossing the stars. For centuries, humanity has looked at the night sky and wondered, are we alone? With each new discovery, exoplanets, mysterious signals, interstellar visitors, we've inched closer to answering that question. 3I Atlas might be just another step in that journey, or it might be the turning point. On the surface, it could be a bizarre comet, unusually rich in carbon dioxide, pure in water, shedding just enough dust to puzzle us, but not enough to explain its glow. Nature is clever, and the universe is stranger than we imagine. But beneath the surface, the coincidences pile up, a trajectory perfectly aligned with planetary orbits. Close flybys of Mars, Jupiter, and Venus. A perihelion hidden from Earth's view. Brightness that suggests either impossible size or suspicious reflectivity. And maybe, just maybe, a glow not of reflection, but of power. If 3I Atlas is natural, then we've discovered an entirely new kind of object. It would mean that interstellar space is seeded not just with rocks and icy comets, but with giant, CO₂-dominated bodies, rare, but not impossible. That alone would be a breakthrough, teaching us about the chemistry of distant planetary systems and rewriting our models of how worlds form. It would also confirm that the cosmos is far more diverse than we've ever imagined. Every new visitor might bring a fresh surprise, showing us that what we thought was normal is only a fraction of the truth. But if 3I Atlas is not natural, then everything changes. Imagine the implications. Somewhere out there, another civilization decided to send a probe, not just to their own planets, but across the stars to us. This would mean we are not only not alone, but also not ignored. We are being watched, studied, maybe even evaluated. The idea is chilling and thrilling at the same time. On one hand, it would confirm that intelligent life is not unique to Earth, that others have mastered the stars. On the other, it would raise 1,000 questions. Why are they here? What do they want? Have they been coming for longer than we realize? And most haunting of all, what happens if they decide to make contact? Think about it. We communicate with spacecraft by programming their paths, their orbits, their maneuvers. Could 3i Atlas itself be a message written in motion? A trajectory designed not to collide, not to alarm, but to hint. To say, we are here, we are watching, and we are capable. For all we know, interstellar probes could be a common strategy, just as we've sent Voyager, Pioneer, and New Horizons into the void. Perhaps civilizations launch them like bottles into a cosmic ocean, waiting to see who finds them. And now, maybe, it's our turn to notice. The next few months will be decisive. When 3i Atlas passes near Mars, we may get our first close-up images of an interstellar object's surface. Will we see cracks of ice and rock, or something smoother, stranger, maybe even metallic? When it reaches perihelion, we may finally witness whether it behaves like a normal comet, boiling and venting gas, or whether it does something no comet ever has. And when it comes closest to Earth in December, telescopes around the world will be waiting. By then, we may already have our answer. And beyond that, the Vera C. Rubin Observatory will start cataloging interstellar visitors by the dozens. If 3i Atlas is an outlier, then maybe we'll file it away as a curiosity. But if more objects like it appear strange, bright, perfectly aligned, then the debate will be over. What's fascinating is not just the object itself, but our reaction to it. Some scientists wave off the alien idea as fantasy. Others embrace the possibility with excitement. The truth is, our species is standing on the edge of a new kind of discovery, one that could redefine what it means to be human. We've always asked the big questions. Who are we? Where do we come from? Are we alone? 3i Atlas might bring us closer to answering the last one. And the answer could either humble us or terrify us. Remember this. Our sun is one star out of hundreds of billions in the Milky Way. Our galaxy is one among trillions. The odds that life exists elsewhere are overwhelming. The odds that some of that life is intelligent are high. The odds that some of it might explore, inevitable. So when we see something like 3i Atlas, an object breaking the rules, glowing strangely, moving with suspicious precision, we should not dismiss the possibility too quickly. Because one day, whether with this visitor or the next, the truth will come knocking. So I leave you with this thought. Tonight, as you look up at the stars, remember that something from another star system is out there right now, drifting silently through our neighborhood. It could be a comet, shedding ancient ice from a world long gone. Or it could be a messenger, carrying with it the knowledge that we are not the only intelligence in the cosmos. The question isn't just what 3i Atlas is. The question is, are we ready for the answer? Because once we know, there is no going back.